Okay, so you have never seen this before. It's called a hole in a function. You've seen these before. What's that thing called? Asymptotes. Asymptote is a spot in the function that doesn't work either. Just to clarify, at -2 here, see that's -2, at -2, the function doesn't work and it creates an asymptote. At +5, which is what's out here, there's something called a hole, and you've never seen that before. I'm going to show you how a hole happens in a function. All right. So do you get that if I stick in a 0, bad things are going to happen here? Because you're going to have 1 over 0. That causes the function to not work. Ask your calculator what 1 divided by 0 is. It'll say error. It can't do it. Okay, so you can't have a 0 down there. That's going to cause either an asymptote or it's going to cause a hole. Let me give you another example. Let's say I had 1 over x plus 5. Now it's not 0 that causes the problem. What would cause a problem if I stuck it in now? -5. Now that's either going to be a hole or it's going to be an asymptote. In the graph, at x is -5, something has to happen. Here's the graph. Here's where -5 is for x. It's either going to make an asymptote right there, or it's going to make a hole right there so that your graph's going along, do, and then all of a sudden, oop, doesn't work right there, and then just keeps going. All right, so now how do you tell which one's which? This kind, I think you already know. We did those yesterday. Those are the kind that have an asymptote. So that would have an asymptote at -5. Not a hole like this. That's different. This would be an asymptote at -5. That looks like this. So how does it look when there's a hole someplace? It looks like this. So which are the ones that are like each other? X plus 5s. Those cancel and create a hole in the graph. So when there's stuff on the bottom that causes weaknesses in the function. This function has a weakness at -4, and this function has a weakness at -5 because it'll make the bottom 0. Those are the things that are not in this function's domain. Those are the things that would screw up this function. Those things either make holes or asymptotes. The kind that cancel make holes. There's a hole at x equals -5. How about this? Why doesn't this make a hole? Because there's nothing to cancel it on the top. So it still causes a problem though, right? So if it's causing a problem and it's not a hole, then it must be an asymptote. So that kind is an asymptote. By the way, it's a vertical asymptote. All right. So far, do you get the idea that the bottom is where functions can have weaknesses? It's only the bottom. We don't care about the top. Do you get if the top becomes 0? Big deal. The answer is just 0. It doesn't like explode. When the bottom becomes 0, that's when you have a problem. And then that problem is either going to be a hole in the graph or it's going to be an asymptote. All right. So I'm going to give you another one. Let's say I had this, x plus 4 and x minus 5 over x plus 6 and x minus 7. Does anything cancel? Does this graph have weaknesses, things that could screw it up? Yes. So the way we say that is its domain. If something's in your domain, it works for you, okay? And the domain is everything works. All real numbers work, except x cannot be -6, and x cannot be -7. No, +7, sorry. Notice these are always the opposites of what numbers are there, because it's the number you could stick into the x that makes it 0. Do you get that -6 and +7 cause issues? Now, they're either asymptotes or they're holes in the graph. So, do you see anything canceling here? So there's no hole. So they must both be asymptotes. you can have two vertical asymptotes. So my asymptotes, my vertical asymptotes, are at x equals -6 and x equals 7. Now I know some of you are like actually trying to picture this. Yeah, there's two dotted lines that go, like one's at -6 and one's at +7. This function has two asymptotes. Yeah, you can have that. Some of them look really strange. You can have 3 or 4 or 10 vertical asymptotes. There's only ever one horizontal asymptote. Graphs can't have more than one of those, but you can have lots of vertical ones. And just so you know how they kind of might look, after I was done, I might have a horizontal asymptote here, and my graph might kind of go like this. Does that look familiar? And then maybe it goes like this. I can't like draw much of that one. And maybe this one goes like this. They do all kinds of strange things. Or maybe it goes like this in the middle of the graph. All right, so I'm knocking you up, trying to do this one step at a time. Which part of the function do we care about, the top or the bottom? Bottom. If we make the bottom 0, it crashes it in one of two ways. What are the two things that could happen? Holes or asymptotes? There was nothing canceling here, so there's no holes. So they were both asymptotes. All right. And if you had a question that said hole, you'd say none. There just isn't a hole in this one. All right. All I'd have to do to change this problem would be to say, okay, I'm going to make this x plus 6 up here, and then it would be different, totally different, because now this would cancel and it would create a hole there. And then this wouldn't be an asymptote, it would be a hole. And I'll show you how to find out exactly where that hole is in the graph. Just so you know what they kind of look like, here is a typical, very typical problem for today. When you're graphing it and it's got a hole, and let's say the hole was at like 5 or something, say this is x is 5, you just have a spot on the graph that just has an empty spot like this. It's like your graph's going along continuously, and all of a sudden, ooh, you'll learn that these are called discontinuities when you get to calculus. We aren't going to call them that now, but just it's not continuous, because at that moment, it stops working. It's called a discontinuity. This also is called a discontinuity because it's not continuous. You can't just draw from the left side to the right side without any hiccups. It's got issues. This one's got two kinds of issues. It's got an asymptote issue, and it's got a hole. All right, now we're going to get back onto the smartboard. Find this one, example 1. Remember the old saying, my favorite saying, if you can factor it, you should. You can factor that bottom part. Would you please do that? And you'll get x plus 3 over something that's factored. I'm going to pause for a second while you factor that. Okay, if you haven't learned how to factor by now, boy, are you in trouble on this next test. Of course, we would already notice it, because if you just failed the last test, it's probably because you weren't good at factoring. All right, and you do have a chance to fix that. The cumulative test comes up after the break, after the holiday break, I guess I should say, a week and a half long or whatever. When you come back from that in January, you get a couple days to review, and then you get the cumulative test right there. It's your chance to fix any mistakes that you've made on the test we're about to take. Actually, I might be off on when that is. Hold on a second. Nope. Yeah, we're going to take this test on Thursday, right before break. Wednesday. We're taking Wednesday, right before break. Then after break is when you get your chance to do the cumulative. So if you do bad on Wednesday's test, I'll try to have your results for you for Thursday so you can know. And if you do bad on that test, you could study over break. I am going to be good, as the principal has requested, and not assign you anything that you have to do over break. But if you bomb this test that we just took, probably would be smart to go back, watch some review videos, do some practice problems, because then the cumulative that you take after break, that's your chance to retake. Both this test and the last test. The last two tests are on this cumulative. Normally have 3, but we don't have time because the semester's ending, so sometimes I've actually seen it where teachers say, sorry, we don't have time to give you the cumulative. You don't get to retake these. But we did a mini cumulative that's only got just the 2 tests on it, not 3. Yes?
What day is it after break? Is it like right after break or is there like...
No, when you come back from break, it's a Wednesday. No, I'm pretty sure you come back on a Wednesday after in January. So you come back for Wednesday, Thursday, Friday. Okay. In there, you're going to have review, test.
So Friday.
It'll be Friday of the week you come back. Okay. So let's continue with this factoring thing. X, and then 4 and a 3 is a typical way to make it 12, but I won't know if it worked until I actually multiply it out. Now I'm going to make this negative 4 and positive 3, and I check and see if I did it right. Negative 4x and positive 3x makes a total of negative x, and that's right. Cool. If I had had the opposite of what I wanted, I would have changed the signs. If I was way off, I would have moved the numbers. All right, so I factored it, and I noticed that something cancels. But instead of just doing that, I got to remember that that just made a hole. That's the new thing for today. When those do cancel, it makes a hole in the graph. Not an asymptote, it makes a hole. Where's the hole? Please don't say 3. The hole's at negative 3. But if you just put negative 3, you aren't saying exactly where the hole was. It's negative 3 comma something. That's a place. It's a dot on the graph that's missing. Negative 3 comma what? All right. This next part is, there's no place to write it. It's not the domain. It's not the vertical asymptote. It's not the hole, but I think it's very important. It's what I call the resulting function. After you canceled that, what was left? There's an equation. I like to say y instead of f of x. Y equals, and then what's left after that y, x plus 3 canceled? There's an x minus 4, but where is it? It's underneath, so what's on top of it? So it's 1 over x plus 4. Or minus 4, sorry. Doesn't that look like the ones we were graphing yesterday? That's a butterfly that's been moved where? To the right. How far? 4. So here's a butterfly. I'm going to try to be kind of careful in how I do it. There we go. I went through the right spot right there, right? And then here's the other one. I went through this spot right there. Okay. Now, I'll try to move it over. First, I'm going to lock this in place. Then I'm going to grab all this and move it over. How far? 1, 2, 3, 4. There's my graph. I moved it over 4 spots. But wait, there's supposed to be a hole in this graph. But I just graphed this. I didn't see any hole. That's because the hole canceled off back here. So how do you figure out the y value of the hole? I know it's supposed to happen at x is negative 3, but how do I figure out the y value of it? You have a good idea, I bet. You plug it in. You plug this in. Plug it into what? Into the resulting function. If I put it back in the original one, it's just going to crash. That's the point. A hole is a bad spot in the function. So if I stick this back in here, it's just going to make it crash. So I put it in the resulting function. I don't put it in here. I put it in there. So I have 1 over negative 3 minus 4. What is 1 over negative 3 minus 4? Yep. You could say 1 over negative 7. Doesn't matter where I put the negative, so there we go. Now, let's actually find that spot on the graph. Before I forget, negative 3 comma negative 1/7. Do you get that negative 3 on the graph is right about here? And negative 3 comma negative 1/7 would be around there. And then my function just keeps going along like nothing happened. It's got a little empty spot on it. There. That's the new stuff for today. The things that crash the function are on the bottom. If either one of them has something cancel it on the top, it makes a hole. Yes?
How did you get the results?
I took the function that I had in the first place, which we had factored down here, and I took out the part that canceled. It was gone. You see what's left?
Yeah.
And there was a 1 on top because when you cancel things, you put a 1 there. Okay, now I never actually answered two questions here. The vertical asymptote. Can you see where the vertical asymptote would be? Right there. And that's at x equals 4. Well, that's the other thing that's left. See? In the resulting function, that's the thing that would crash the function still. So there's two ways to crash a function. It could either be a hole or it could be an asymptote. Turns out that the asymptote is the thing that's left after you've canceled off the hole. And last but not least, the domain is checking, do you understand what domain means? Domain means what can you safely feed your function. If you have a dog, you probably know by now that you can't safely feed your dog chocolate. You can make it, depends on the dog, depends on the size of the dog, depends on a lot of things, but it's generally not safe to give your dog chocolate. Now, I don't want to, I'm sure there's an exception to every rule, but I know there are dogs that have died from eating chocolate. So you got to be really careful, and don't tell your friends, don't worry, it won't hurt your dog just because your dog makes it. Be careful, because dogs are generally allergic to chocolate. All right, so anyway, Kelly, we can talk about that later. I'm curious how your dog survived what. But if I put the domain down as just all reals, I'm saying everything is safe to feed this function. Is everything safe? No. There was two things that could hurt this function. You can't let it be 4, and you can't let it be -3, because this would make a hole, and the other one would make an asymptote. No, that's a y value. Domain is about x's. All right. Now, if you're feeling a little bit like, whoa, this is complicated, I see a lot of faces that look that way, and it's okay. I know that this is usually a tough day. This is kind of pre-calculus sort of stuff. This is on the harder edge of what we do. I warned you, this is not one of the easy days. All right, so let's go to the next one and try another practice problem. Okay, at this point, you get how I really wanted you to know how to factor. Why? Because it just keeps happening. Yeah, if you can't start by factoring it, you won't be able to ever find where the hole is. So factor this. Try to figure out what are the things that you can safely feed your function. Is it really just everything, all reals? Or is there something that you can't let x be? Your vertical asymptote or the vertical asymptote, so you should know x equals something is your vertical asymptote. The things that crash your function are either holes or asymptotes. And I'll give you the hint, there is a hole in this one. And you got to figure out, is it at like 2, 1/8 or something? Where is that hole? I'm going to pause while you give this one a try. So you by now either know that you don't know what to do, or that you totally got this. That factored into that. That's your first step always, is factoring. Now this is gone, and it's factored into that. Next, this cancels. Can I just forget about that stuff? No, because it made a what? A hole. But the resulting function is y equals that. I'm going to write that down. Y equals x plus 2. Doesn't it look so simple? Y equals x plus 2. It's just like a line that goes through here and has a slope of 1, and it looks like this. So how is this like even possibly that simple? Because it's a straight line, yes, but it's got a hole in it. Where? Right there. The 2 was something you could feed your function that would hurt it. Do you get how if we put a 2 right here, it would cause issues? So you should have said, it's all real numbers, except x cannot be 2. And the vertical asymptote is, there isn't one. Why isn't there an asymptote? Because the one thing that can hurt the function isn't the asymptote, it's a hole. So there was none. Look at that straight line. It doesn't have an asymptote. See? Makes sense that there wouldn't be an asymptote. The one thing that hurt it here was a hole. And that hole is at 2, what? Well, you take the 2, you stick it back in the resulting function. This goes in there, and it tells you y equals what? 4. 2 comma 4. So now I'm going to go over to my graph, and at 2 comma 4, which is right there, it seems like there'd be a dot there, but there isn't. There's an empty spot right there. And I go empty spot. There. There's my answer. Is there any part of that you'd like me to explain over again? How'd you get this? Yes?
So what was the domain?
The domain was all real numbers work, that's the big R, except x cannot be 2. Because if I put a 2 in, it'll die. And you might be thinking, but 2 doesn't hurt it over here. No, in the original one. The original function was right here. Do you get how 2 would hurt my function? And 2 would make a hole in the function, and that is considered not part of the function. That means it doesn't work right at that spot. So the domain is what works. Everything works except x cannot be 2. Any other part you want explained? All right, they always start with factoring. This one's factored by grouping. Get this one factored by grouping. Can you unplug from the one here? Thank you. And once you got it factored, something will cancel. That's going to make a hole. Remember, the things that crash the function are on the bottom, and they're either holes or asymptotes that crash the function. I'll pause for a minute while you give this one a try. Okay. Did you factor the top? X squared came out, and then -1 came out. If you didn't catch that last part, if you were like, but they aren't coming out the same, then you weren't factoring the right thing out. Now I got an x plus 3 that's going to come out, and I'm putting x plus 3 in the front of my equation, and then what's left after these come out is x squared minus 1. But I'm smart enough to know that that's x plus 1 and x minus 1. You don't have to have factored that, because the main thing we had to get factored was the x plus 3. Because why? Because there's 1 on the bottom too. And that creates a hole. Okay, so those two cancel and create a hole. And the hole is at something comma something. It's at 3 comma, nope, that's the most common mistake. If I put in a 3, it doesn't crash, it just makes 6 on the bottom. If I put in a -3, it would crash. So -3 comma what? Well, you put the -3 into the resulting function. This is what's left over. I'm going to rewrite it down here where it's nice. Y equals x plus 1, x minus 1. And if I stick in a -3 in there, it'll tell me -2 times -4 is +8. How many of you had the hole at the right spot? -3 comma 8. Okay, cool. Then, what's the vertical asymptote? None. This only thing that caused us trouble, this thing, this little troublemaker, was a hole, not an asymptote. So there is no, asymptotes. None. And the domain, all the real numbers work. If you just write that, it is sufficient, if that's right. Do all the numbers really work? No, you got to make sure that x is not -3. There we go. Now quickly, if I wanted to get the graph, I'll just show you quick. I could multiply this back out in this x plus 1 and this x plus 1, this guy right here. That's really x squared minus 1. That's just a parabola that's been shifted down 1. Do you get that it generally would look like this? But up here somewhere, there would be a hole in it, right above -3. See this -3 right here? If you go straight up from there, there'd be a hole there somewhere at -3 comma 8. Okay, that's the new stuff for today. And you don't have to be the master of it yet. We aren't testing on it until Wednesday of next week. Okay, so you can do a lot more reviewing. We have a little bit of new stuff on Monday. Tuesday's review. Wednesday's the test. And that's all I got for you for today. Okay, wait. I want to tell you what problems you can do on the homework. Today is another one of those days where I feel like the homework's a little bit long, so we are just doing evens. So let's look at the homework worksheet together here and start the evens. Do you see something that's going to cancel and create a hole?
Yeah.
All right. So that cancels and creates the hole. Where is the hole? Something comma something. I'd always start with that to remind yourself, don't just say -3 or 5 or whatever it is. In this case, it's -5 comma what? Well, you got to go with what results. When this cancels, some kids think there's nothing left. There's actually a 1. So it's y equals 1. Now, if I put a -5 in that, you don't put it in the y. This is an x. And this is kind of weird, but I can't put the -5 anywhere in it because y equals 1 is just a line that runs forever. Doesn't matter what the x is. It's this. It's a line that runs forever. And so if it says y equals 1, guess what? Y equals 1. Because you're asking what the y is. By having an empty spot there, you got to think, okay, so I need the y. It says right here, y equals 1. Maybe the answer is 1. All right, so now if I was actually going to graph this, you don't have to, but I want to show you. I go to -5, and I go up to the function. I put a hole right there. So I'm going to erase and put a hole. It won't let me erase. You're going to have to take my word for it. I would erase right here, and I'd put a hole in right there. Empty spot. The empty spot came because -5 we know causes a problem, makes a 0 on the bottom. That's either going to be an asymptote or it's a hole. The reason it's a hole is because the thing that was on the bottom is also on the top and it cancels. All right, let's do number 4. Can you factor that? I can. X plus 2x minus 2. That should be like second nature by now. And then that cancels. What's the resulting function? Y equals x minus 2. Because the other part canceled. When it did that, it created a hole at -2 comma. Here's the hard part. What do you do with that again? Go back, put it back into the resulting function. That goes right there. And then you have -2 minus 2, which makes -4. That's where the hole would be. -2 comma -4. If I put a -2 right here, I want you to reassess yourself.
Yeah, but
what's -2 minus?
Why is it not positive 2? It should be a positive 2, then isn't it like...
Wait. Is +2 the thing that causes a problem?
Yes.
Nope. Look, if I put a 2 right here, +2 does not cause a problem. You're getting confused about what crashes this function. 2 does not crash this function. What crashes this function? -2. That's why we start with -2 right here. -2 crashes the function, not 2. I know some of you are thinking, but the top, if I put a 2 in here, it'll crash it. No, it makes it 0. That's different than crashing. 0 on the bottom of a function was what causes the problem. So again, I know some of these people are thinking, if the top becomes 0, then I have issues. No. The top can be 0. It's the bottom. It's the bottom you have to worry about, right here. How do I make that 0? Because that's what would crash the function. So -2 is where the hole is, not 2. All right, now I'm going to put the -2 somewhere. I stick it over here. -2 goes in there. And I get -2 minus 2, which makes -4. I do get what you're saying. But you got to get out of the habit of looking at the top. The top, I don't care if that's 0 on top. That doesn't hurt anything. So -3 is not an issue on the top. It's an issue on the bottom, and that's what counts. So can factor it, you should. If you need extra practice, you can also go do the odds here, but I'm only assigning the evens. All right. So this is due on Monday. Then I teach you one last thing on Monday, review on Tuesday, test on Wednesday is the current plan. All right, that's all I got for you for today.